So good afternoon, everyone. As Jules said, my name is Samir, and today I'm going to talk about some of the major features in Apache Spark 2.3. So just a brief introduction about me. I'm a Spark committer and the release manager for the 2.3 release. I'm currently a software engineer at Facebook, where I work as part of the big compute team. Previously, I spent several wonderful years at Databricks, where I focused on Spark Core and Spark SQL. And before that, I was at UC Berkeley, where my research focused on BlinkDB, which is an approximate query processing framework that's built on top of Spark. All right. So before I actually start this talk, let me try to give a brief overview of the Spark 2.3 release by just sharing some numbers. So Spark 2.3 was released on 28th February of this year. And this entire development spanned across around 7 to 8 months. So it started around July of last year, and then it went ahead until the February of this year. We are extremely fortunate as a community to be so active. We had 284 unique contributors to Apache Spark. And in some ways, if you put that in perspective, as a release manager, it's very humbling for me to give this talk, because I'm really talking about this amazing work that hundreds of people have actually done and contributed to Apache Spark. Together, we actually closed over 1,400 JIRAs, which basically comprised of SQL and streaming, Spark Core, PySpark, and machine learning, among many other things. So Spark SQL and streaming actually constituted a majority of the JIRAs that went into the Spark 2.3 release. We had a bunch of very amazing stuff. We basically added the support for continuous applications in Spark streaming. We have support for stream joins. On the SQL front, we have this whole new data source API v2. We did a bunch of optimizations under the hood for the Catalyst optimizer. There is essentially awesome support for our extensions for the cost-based optimizer. We added support for histograms, among many other things. Spark Core essentially comprises of the Spark scheduler, the block manager, the memory manager. And here, the highlight of the release was actually adding a whole new Kubernetes backend that was shipped as part of 2.3. PySpark, essentially, a lot of focus went around performance. So I'll talk about this in the rest of my talk. But essentially, at a high level, we added support for vectorized UDFs in Python, which essentially allow you to run, or they are actually 3 to 100 times faster than the row at a time UDF that are previously supported. And then last but not the least, machine learning is extremely growing in popularity. And on the ML side, we actually did a lot of work in unifying the APIs such that it's basically a common API for batch and streaming, and did a lot of work around adding image-based data sources in Spark. So while there are so many things, in this talk today, I'm actually going to talk about 4 major features. So first, I'll talk about continuous processing, which is probably the most interesting thing that went into Spark 2.3. Then I'll talk about streaming machine learning, which actually combines streaming and machine learning into a single API. And along with that, I'll talk about the image reader format that shipped as part of 2.3. Then I'll talk about PySpark Performance. And essentially, as I mentioned, it basically speeds up UDFs in Python that would immensely benefit data scientists who actually rely on these UDFs. And finally, I'll talk about the Spark on Kubernetes effort, or this new scheduler backend that was shipped as part of Spark 2.3. So now, as I mentioned before, Spark 2.3 actually had more than 1,400 JIRAs that were closed. And they basically spanned multiple bug fixes, multiple features, so many things. And I don't really have time to go over each of these things in this short 30-minute talk. But here are some more highlights in addition to the 4 things that I'll talk about. So besides continuous processing, Spark on Kubernetes, PySpark Performance, and ML streaming, one of the very exciting things that went into Spark 2.3 was this whole new data source API v2. So this is an experimental release of this new API that actually builds on v1, the data source API v1, and tries to address many of the shortcomings of this v1 API. So while we have actually kept v1, it's not going away. But this new API is basically designed to be much more developer-friendly, and it would hopefully allow creating richer ecosystems and much more richer integrations with the data sources, various data sources in Spark. Then we actually did almost a complete rewrite of the Spark history server v2, such that it's much more robust and less, it's basically not going to anymore. And then finally, one of the really interesting things that also I'll probably skip today is this whole stream joins that actually give us this declarative API for joining two streams of data. And at this, basically, in this case, like Spark actually has like very good support for watermarking, kind of like maintaining state such that it does not exceed beyond a certain capacity. So a lot of interesting work there. And then we have a whole new kind of like very interesting work around native ORC support in Spark. Code genning, like the code gen essentially got around a bunch of limits around like 64 KB JVM limits. We had a number of SQL features, so essentially the cost-based optimizer now has histogram support. There are a number of tons of fixes that went in how we read our caches, so it's columnar, and then essentially there are a number of features that went into the catalyst optimizer as well. So again, I will not have time to talk about all of these things, so I just basically picked 4. But if you're interested, please do go to this link. This basically has the release notes, which basically elaborates over all of these excellent features. And it also talks about many other things around just basically deprecations, differences in API, and much more. All right, so let's get started with continuous processing. So Spark streaming was actually introduced in Spark 2.0. And this was a whole new effort of decoupling the high-level API that the user sees with this Spark's micro-batch execution engine. Now, this actually meant 2 things. From the user's perspective, it allowed users to treat a stream as just an infinite table, right? So basically, the user did not have to worry about or reason about micro-batches in general. And then, essentially, since this was built on Spark SQL, it basically gave us all the optimizations, the catalyst optimizer, join, filter pushdowns, or like things like this for free. So it was much more performant. Now, this was the user's perspective. From the developer's perspective, it had a very nice side effect of actually decoupling the high-level API with the query's execution engine, right? So what this meant was that under the hood, we could actually change, or we could kind of like optimize the execution engine without having to worry about the high-level APIs, because the logic was not leaking through these high-level APIs. So to be more concrete about it, structured streaming in 2.0 actually had something like this, in which the user could actually write a query using the data frame API or a SQL API. So in this specific case, I have some data frame in which we are doing a filter on a state, and then grouping by a time window of 30 seconds, and then finally computing some average latency on that window. So in this specific case, it does not matter whether the query is referencing input streams or static tables. Spark would just basically come up with a plan, and then it will just go through this incremental planner, would go through the catalyst optimizer, and at the very end, it gets executed on the micro-batch execution engine. Now, what happens in the micro-batch execution engine is something like this. So at the bottom, you essentially see this infinite stream, or this input stream that is coming, and Spark is actually dividing the stream into small micro batches, right? So these are like basically logical construct. And as far as the driver is concerned, it does 2 things. First, it logs these to be process offsets. So essentially, I have like these micro batch boundaries, and the driver actually logs these or saves this to a write-ahead log. And then it actually launches a series of very small tasks that each micro batch can then process. So what does this mean? This actually means that, first of all, whenever each micro batch is processed, there is an inherent latency involved in launching the task. So anecdotally, like, I mean, Spark tasks take about 100 milliseconds to launch, which means that for processing each of these micro batches, you have to at least wait for 100 milliseconds. And then more practically, you would want to kind of like wait for a chunk of data, and then that basically means that practically the latency is several hundred milliseconds. Then the second thing is, since you're logging the offsets before actually started processing, you actually get these nice exactly one semantics with this model, right? So this was Spark 2.0. It was this micro batch execution model where you were treating streams as an infinite table. You have this like divided into micro batches, and then ultimately you have these short tasks that launch on these micro batches. Now, what happened with Spark 2.3 is this new mode that we introduced, which is called continuous processing. And this is basically being tracked by Spark 20928. And as part of this, the high-level API, again, remains the same. So you still have this whole data frame API or the SQL query that gets converted into a plan that can reference streams or Spark tables, still goes through the optimizer. And now the user actually has a choice. So they can still go through the whole old micro-batch execution model, which is still the default, or they can actually have or switch to the new continuous processing model. Now, what does this continuous processing model give us? In the continuous processing model, we still have the stream of data coming in, but unlike the micro batch processing model, in this case, as soon as the query is submitted to Spark, the driver actually launches these long-running tasks. So the driver is not launching tasks on a per micro batch level. There is just this long-running task that was launched when the query started, right? So no longer the task launch time is no longer the bottleneck. And then essentially these tasks actually start processing the events as soon as they come in. So they don't have to really wait for like these events or like batch them before they come in, right? And at periodic intervals, these events are then logged to a write-ahead log. So the events are processed, and then at periodic checkpointing intervals, these are logged to a write-ahead log. Now, if you contrast with the semantics of micro-batch processing, this has two differences. One, since we don't have to launch new tasks when each of these events are coming in, you don't actually incur this 100 milliseconds or several hundred millisecond latency. So in this case, you're practically getting zero latency or like a millisecond latency in processing these events. So you can actually process them as fast as you want. And second, since we are actually processing the events and then logging or checkpointing them, in this case, we get at least one semantic. So Spark would guarantee that you will process the events at least once. Now, as far as the API is concerned, it's actually very beautiful. It actually works in exactly the same way as Spark 2.0. And the only change that you have to do in your query is to basically specify this trigger. So you don't have a processing time trigger, which basically used to originally specify the time or the time interval for the micro batches. And you can just say that, hey, just specify a continuous trigger with this checkpointing interval. You can say it a 1 second interval. And then Spark would just basically, in this specific case, it's reading from a Kafka stream. As soon as the events are coming in the Kafka stream, it would just start processing it and then do some kind of like operations on this. In this case, it's just casting some things, and then write it back to a Kafka string. So again, this is going through the continuous processing model. No, like practically zero event latency, like processing latency. And then this is actually going to give us at least one semantics. So what's supported in the continuous processing model? Continuous processing model is marked as experimental for the 2.3 release. And it supports all map-like dataset operations. So you can have basically support for projections, selections, and things like this. Anything that allows you to kind of like peek and like look into the records as they are coming in at like full speed. And then we support pretty much all SQL functions except aggregate functions for now. In terms of sources and sink, we actually have out-of-box support for the Kafka source and sink. And then we also support the rate source and the memory sink and console sink for testing. So this is kind of like a brief overview of the continuous processing feature in Apache Spark. If you're more interested in kind of like learning more, I would refer you to the Databricks blog on continuous processing. And this kind of like goes into into much more detail than I talked about. So it kind of like goes into like performance. It talks about like many of these semantical features, the architecture, and many other things. So next, let's talk about streaming machine learning and this new image reader support that was shipped as part of Spark 2.3. Now, if this whole summit is kind of like any indication, you all know that machine learning is just exploding. And there are people who are using Spark who really want to kind of like have access to machine learning and kind of like train their models. And once you train the model, the next kind of like obvious step is to actually validate that model. Now, as far as validating a model is concerned, or just basically running it on some data is concerned, one way of doing this is to basically put it as part of an asynchronous streaming pipeline. So in this case, you can imagine that you have like the sequence of events coming in into a message bus like Kafka or Scribe, and then you basically run a structured streaming job to process them. So in the past, a lot of this, actually like writing a lot of like things that I just talked about, required stitching like a lot of like this code and like gluing together many things, which kind of like was very ugly and clunky. Now what we did was we have actually changed the machine learning pipeline in Spark to be able to directly work on streaming data. So you can basically have the same code that works for batch and streaming and run them on basically this pipeline. The second thing I'm going to talk about in the machine learning domain is this new image support in Spark. So the deep learning frameworks are now just growing in popularity. And one of the kind of like nice side effects of this is that images are actually now becoming an extremely important data source in Spark. So now, I mean, essentially just kind of like, I think I heard this yesterday, but someone was saying, like, whenever a new learning framework actually tries to kind of like integrate with Spark, they now have to kind of like think about crafting their own APIs, trying to kind of like see how they would like to store the images, how to process them, and things like this, right? So a lot of like duplication is going on with that. And that kind of like is a barrier that you would like to avoid. So this actually is an excellent kind of like way of solving this problem. The community actually got together, engineers from Databricks and Microsoft, and they actually decided to create a standard API for reading images in Spark. And essentially, this also required creating a standard like encoding that Spark could understand and basically share with the deep learning frameworks. So this actually resulted in adding this first-class support for images in Spark. So essentially, you would just basically have this folder containing your images, /data/images. And if you run image schema.read_images on them, Spark would automatically read all these images, and then it would basically just construct a data frame with all these images. So internally, Spark stores these images, as you would imagine, with some metadata. So origin, height, width, and things like this. And then the data, the image data itself, is this binary data that's actually stored. My bad. And this binary data is compliant with the OpenCV format. So it's actually something that many deep learning frameworks can actually understand. So next, let's talk about PySpark performance in Spark. So PySpark was introduced in Spark 2.7 nearly 5 years ago. And then it became a first-class citizen in the data frame API in Spark around 2015. Now, if you've ever worked with UDFs in Python, one of the kind of unfortunate things that you might have noticed is that these UDFs are actually much slower than their Java or Scala counterparts. Now, this happens because of two reasons. One, the Python interpreter itself is actually slow. So, I mean, you basically incur that overhead when you're trying to invoke UDFs in Python. But the second more important reason is that given that these UDFs are actually processing the data row at a time, what Spark is really under the hood doing is that it's trying to kind of like process these or ship these rows to the Python process from the JVM. And this incurs a lot of serialization, deserialization overhead. And that is what really is like slowing things down. Now, one interesting side note here is that most of the PyData tooling that we have, so when we talk about NumPy, Pandas, and things like this, they're actually just written in C, C++. So there are Python wrappers around them, but I mean, essentially, inherently, the code that's actually doing or computing the logic is just written in C, C++, which means that inherently, there is no fundamental reason of them being slow than their Scala or Java counterparts. So this insight actually led to this whole effort on vectorized UDFs in Python. And essentially, instead of passing the data row at a time that I previously talked about, this whole kind of like notion behind vectorized UDFs was to basically encode the corresponding data in batches or in some kind of columnar format, and then pass this batch to Python kind of like grouped together or batch at a time. So this basically means that the serialization cost is not incurred on a row-by-row basis. You just end up amortizing the serialization cost over the entire batch. And then one interesting side effect of this is that the PyData tooling that I just talked about, NumPy, Pandas, and all these kind of things, they already are very good, or they're designed to work on data in columnar format. So they kind of like expect the data to be in the columnar format, which means that there is actually no additional like serialization, deserialization cost on their front. And it's actually literally as fast as operating on native code or running native code. So this graph here in this figure actually compares the performance for row-at-a-time UDFs with these pandas or the vectorized UDFs that we have. So we have like a few examples here. The first UDF kind of like tries to add a number to like a corresponding like column. Second UDF computes the CDF, and the third UDF tries to kind of like subtract the mean of a group from like this particular thing. So overall, I think the takeaway point is that Python UDFs or the vectorized UDFs actually are almost 3 to 100 times faster than row-at-a-time UDFs. And depending on like how complex they are, what kind of data that they are trying to ship between the Python and the JVM, you actually see these gains increase. So to be more concrete about the APIs, as far as the pandas or the vectorized UDFs are concerned, we have two types. We have the scalar UDFs, which are actually used with functions such as select and with column. And essentially, these Python functions basically essentially takes in a pandas.series, which is essentially a wrapper around NumPy arrays, and then it also returns a pandas.series. So code-wise, it basically looks something like this. So you have an annotator or a decorator like pandas.udf, and you basically specify that it's a pandas UDF type.scalar. And then essentially, you could write a function. In this specific case, it's just like pandas +1, and then returns by just incrementing v +1. So it's returning a pandas.series of the same length and just adding some number to it. The next, the second one that we have in this category is basically called grouped map UDFs. So these grouped map UDFs actually work on this popular paradigm of split, apply, combine. And what this really means is that it essentially operates on group data. So you can imagine, let's actually look at the example in which like we're doing df.group by ID. So it allows or basically tells Spark to first do a group by, and then Spark actually ships these serialized groups to the Python process. And there is a Python function that actually defines the computation for each group. So in this specific case, I mean, we have the subtract mean example. And here, essentially, you are actually just operating on a data frame, first of all, grouping by this ID. And then you're trying for each group to iterate over all of these entries and then try to subtract the mean of the values of this group. Right? So this is an example of the group map UDF. And as you saw, they basically are around 100 times faster for Python. So last but not the least, I'll talk about the Spark on Kubernetes effort. So traditionally, Spark actually started as a research project in Berkeley. And one of the first kind of like motivations to start Spark in the first place was to actually have it, implement an execution engine for Mesos besides Hadoop. Over time, Spark obviously grew too much in popularity. So we added a standalone scheduler mode, followed by Yarn. And then with Spark 2.3, we have now added an experimental support for the Kubernetes scheduler. Now, in this feature, Spark actually runs in the Kubernetes pod created by the submission client. And this, in turn, like the Spark scheduler, then in turn can launch or run further executors in these pods in response to like the load or the requests. And this essentially is pretty natively integrated with the Spark code base. So this means that like we can actually make use of pretty much all DevOps nice DevOps-friendly features that actually Kubernetes provide, including kind of like namespaces, quotas, pluggable authorization, logging, and all these kind of things. So what's there in Spark Kubernetes? In Spark 2.3, we actually support Kubernetes 1.6 plus. We support cluster mode for now, because the driver and the executors actually run on these Kubernetes pods. The client mode is coming up and should hopefully be supported in future versions of Spark. We currently have static resource allocation and dynamic resource allocation, and the whole external shuffle service support is hopefully coming in the future versions. We have Java and Scala application support for now, and then Python and R would be in subsequent release. And then we have basically these container local and remote dependencies that are downloadable. And in future roadmap, we have basically client local dependencies and this concept of a resource staging server that we'll have. All right. So just to recap, I talked about 4 things in this talk today. We talked about continuous processing, which is this extremely low latency streaming engine that is shipped as an experimental feature in Spark 2.3. And the whole idea behind continuous processing is this like long-running task that try to kind of like process these events, the streaming events, as soon as they are coming. And then they try to kind of like basically give you 0 to 1 millisecond latency and at least 1 semantics. On the streaming and on the ML front and the image reader support, we actually have this unified APIs for doing machine learning on batch and streaming. PySpark Performance, we talked about vectorized UDFs. So essentially, they are of 2 types. We have the scalar UDFs, and then we have the group map UDFs. And they are around 3 to 100 times faster than their row-at-a-time counterparts. And then finally, we talked about the Spark on Kubernetes support, which is essentially this new scheduler backend that allows you to kind of like run Spark natively on Kubernetes. So with that, I conclude my talk, and I'll be very, very happy to answer any questions. Thank you.
Thank you, Samir. We got about 4 minutes. Any questions? Yeah.
Hi, Samir.
Hi.
Quick question about the Pandas UDFs. I noticed that to declare a Pandas UDF, you have to write this decorator and invoke it with the right, or give it the types of the function that you're trying to turn into a Pandas UDF.
Right.
I was wondering, was there any discussion on the dev list? I would have noticed, I guess, but maybe I didn't, about maybe leveraging Python 3 type annotations to let you just immediately convert that into a Pandas UDF without separately specifying the types in the call to the decorator?
That's a good question. I think there was some discussion around using the Python 3 annotations, but I'm not sure how that plays with like essentially backwards compatibility with Python 2. Right. So do check out the Jira. And again, like this actually feature was led primarily by folks in the Arrow community and Two Sigma. So
what's the guy's name from the Arrow?
Legion.
Arrow is Wes McKinley, and Legion is the guy from yeah.
Any other question?
So for Spark on Kubernetes, do you have support for the driver pod not being moved by Kubernetes?
So you mean to say client mode kind of a thing?
I mean, if the Kubernetes tries to move the driver pod, the driver will die, right? Because the driver cannot really be restarted.
So not in this version. So basically, okay. Yeah, this hopefully would come in like in 2.4 or
2.4.
Yeah.
Okay.
Any other question? I'm going to go on stage.
Yeah.
When is supposed to be launched Spark 2.4 with the support for PySpark on Kubernetes?
Sorry?
When is supposed to be launched the next version of Spark for supporting Kubernetes with PySpark?
Supporting what with PySpark?
PySpark in Kubernetes.
Oh, in Kubernetes?
Yes.
I think you can still use, well, I mean, essentially, so yeah, I think it should hopefully be released as part of the next release. Whether it's 2.4 or 3.0, it's still being debated on, but yeah, there is.
When is supposed to be launched?
I think, it's hopefully end of this year, but it really depends on like community voting and queuing and things like that.
Okay, thanks.
I mean, there is discussion going on in the dev list, some of the features, whether it's going to be 2.4, 3.0, it's not known yet. Okay. Anybody else? We'll take the last question.
Actually, I have two questions. Quick question. First question is for those image kind of ingestion API. Is that considered the PDF as image too, or is only considered like PNG and other traditional PDF?
So the question is around which API?
The image.
The image scanner. There is some problem with the mic, right? I can't.
Could we actually turn on the mic? You just take this putting the mic.
Sure. Go ahead. So you're talking about the image API, right? And the question is whether that image API is kind of
Also consider PDF as like image or like image capture to the PDF.
I think it does not, but do check it out, right? I mean, I think the image API does basically support standard image format, and basically it supports like whatever image format OpenCV supports. But yeah, this might be something.
Yeah, I
to
mean,
check
right
out.
now it just supports PNGs.
It does not do PDFs, right?
It doesn't do PDFs.
Makes sense.
I have another question. Another question will be for the continue API, kind of like continue processing the data feeding to the Spark. That one, you mentioned the aggregated function is not available now.
Mm-hmm.
So that means I cannot do group by or something like that, right? So I understand that one, but where those data cannot point a storage into? For example, if I'm processing average, right? Mm-hmm. And because it's continual, right? I'm imagining like every single time if you have a data point come in, you will recalculate the average and generate that.
Right.
But where that calculation happening right now?
So the question is whether, or I mean, if I understand the question correctly, you're asking that continuous processing right now does not support aggregates, and what's the plan around that? So basically, I think like the reason why continuous processing did not support aggregates to begin with was just because like, I mean, essentially getting the low latency for these like stream of events as they're trickling in for aggregates made lesser sense as opposed to basically these selections and projections. Just for basically, for aggregates, you can still use the micro batch execution model, and like maybe if you're anyway aggregating over the events, 1 versus 100 milliseconds might not like make too much difference. But that said, I mean, essentially the community might actually think like, I mean, in case like this is something important, then it might actually come in subsequent releases of Spark.
Thank you.
All right, thank you very much. I think we're all done for today. Somebody will answer the questions at the back. We have two speakers coming in. You can just